Hello and welcome to part 2 of step 4. So in part 1, we talked about inductive reasoning a little bit. So this is when we looked at examples or observations to make a conjecture. We looked at the list of movie times to try to figure out when we think the next movie time would be. But there was really no rhyme or rule for us to decide those things. So the next thing we're going to talk about is deductive reasoning. This follows facts and rules, definitions, or properties to figure out what the next thing is. So the first thing we're going to talk about is just differentiating what's inductive reasoning and what's deductive reasoning. Okay? So this first one, every time Lauren has a healthy meal before her run, she is able to run further than her sister who does not like healthy foods. Lauren has eaten a healthy meal, so she concludes she will run further than her sister. So what we want to ask ourselves is, are we recognizing just a pattern and observation of what's going on? Or is there an actual rule that, if Lauren eats the healthy meal, then she will for sure, because there's a rule or a definition, that she's going to run faster? And the answer is this is just simply an observation, right? She doesn't know 100%. She knows in the past that this has helped her, but we don't know that there's some sort of rule of what she has to eat before she runs. So this is going to be inductive reasoning. Okay. If John is late making his car insurance payment, he will be assessed a late fee of $50. John's payment is late this month, so he concludes that he will be assessed a late fee of $50. Okay, sounds reasonable. So we want to ask ourselves, is he basing this on an observation, something that he's noticed in the past, or what noticed when he's missed a payment? Or is this a rule that if you do this, something is going to happen? And hopefully you're thinking, well, it's a rule, right? If it's late, he has the late fee. There's no ifs, ands, buts about it. So if we're following a rule, this is going to be deductive reasoning. My handwriting is great today. Whew. All right, moving on. So then we kind of move into this law of detachment, which is kind of what we were just talking about. Recognizing a pattern within our sentences, okay? Like, what was that first one? What was her name? So Lauren, right? She ate a healthy meal. She's going to run faster than her sister. Today she ate a healthy meal, so she's going to assume that she's going to run faster, okay? So our law of detachment allows us to, if we start our sentence the same way, with the same beginning, our conclusion can be the same. So for example, if a car is out of gas, then it will not start. Sarah's car is out of gas. So we can assume, right, that it's not going to start, okay? Notice the beginning of this sentence, it's both in red. That's why it started the same way. And then therefore we can make the same conclusion. If the sentences do not start the same way, then you could not make the same conclusion. So let's look at an example of this, okay? If two angles form a linear pair, so that's the beginning of our sentence. If two angles form a linear pair, then their non-common sides are opposite rays. Okay, that seems reasonable. The second sentence starts with angle AED and angle AEB form a linear pair. Okay, does that match either part of our sentence up above? That we have two angles listed and they're forming a linear pair. Hopefully you're recognizing that it's matching the part of the sentence in yellow. Okay, and then ray ED and ray EB are opposite rays. Okay, and that happens to match the blue part, the second part. Okay, so the sentences both start the same and they make the same conclusion. Okay, so they're basically just reiterating itself, right? The first one is kind of making an overall judgment call, like an overall rule. The second statement is giving you an example of how that applies. Okay, so this is a valid way to say this. That works. Okay, the next one's a little less geometry on you. If Mika goes to the beach, so we'll highlight that. If Mika goes to the beach, she will wear sunscreen, right? We're going to the beach, we're wearing sunscreen. Then we say Mika is wearing sunscreen. Well, that is the blue part, right? Her wearing sunscreen, not going to the beach. And then we have Mika is at the beach. Oh no, this isn't good. So in a situation like this, we would want to ask ourselves, so the rule is she's going to the beach, she's wearing the sunscreen, right? We got to protect our skin. But if she's wearing sunscreen, do we know 100% that she's actually at the beach? The answer is no, we don't know, right? Maybe she's just going outside to play with her friends and she has to put on sunscreen. So this is an invalid statement. This one would not work. We're reiterating the same information in both sentences, but not in the correct order, right? We would need to know that she's going to the beach first to then assume that she is wearing sunscreen. All right, let's keep moving. Okay. Determine whether each conclusion is valid based on the given information. If not, write invalid. So if a primate is an ape, then it does not have a tail. Coco is a primate who does not have a tail. Coco is an ape. Ooh. Okay, interesting. So our first sentence sets us up that we have apes. Okay, if a primate is an ape, then it does not have a tail. Okay, so we have primates, right? So if we were going to draw like a Venn diagram. So if we're going to draw a Venn diagram, we're going to want to make sure that Coco fits, right, in our Venn diagram here. So we're basically comparing things that are apes and things that have tails, right? So we would show that we have apes over here and primates that have tails over here, right? We could show that inside, or we could even draw a bigger picture, that apes would be inside of having tails, okay? So Coco is a primate who does not have a tail. So she's not going to have a tail. She's not going to be in our circle of having tails, right? But is she necessarily an ape? Can we make that jump? Are there primates that don't have tails that are not apes? And the answer is probably. I honestly can't think of anything off the top of my head. But Coco could be here. Maybe she's here. But she could be here. We know she's not in the having tails section. But we don't know for sure. Just because she doesn't have a tail doesn't necessarily make her an ape. Okay? So this is an invalid statement here. Okay, not sure. Could work, but not 100%, so we can't say valid for sure. Okay, and then we have this law of syllogism. Okay, this is kind of like the law of detachment, but just slightly different. So we're looking at statements again, given two statements, and trying to decide, can we write a valid conclusion or not? So this one allows us to kind of cut out repetition that we're saying. So in this example, if you get a job, you'll earn money. If you earn money, then you will buy a car. It kind of sounds like a long run-on sentence, right? We've repeated ourselves. We don't necessarily, when we speak, like to say, you will earn money twice back to back. So you notice that this sentence ends with you will earn money. This sentence began with you will earn money. Okay? So because we have that repetition back to back like that, we can actually cut it out. We don't need that step in our logical reasoning, and we can just say, if you get a job, then you will buy a car. Oh, I don't like how that turned it green there. Let's erase that. just underline it. Oops. Okay, so we're basically cutting out that long run-on sentence here. Okay, so determine whether each statement is valid based on the information. If not, write invalid, explain your reasoning. Okay, so ours is starting out. If you are an actor, then you enjoy musicals. If you enjoy musicals, then you enjoy theater productions. Okay, so hopefully you're seeing that the end of the first statement and the beginning of the second statement are the same. We've repeated ourselves, okay? We don't like to repeat ourselves. So our first sentence says, if you enjoy musicals, then you are an actor. So both of those phrases are there, right? If you enjoy musicals matches the blue part, then you are an actor is the yellow part, but they're not in the same order. So we can't make this a valid statement because we can't go backwards in the way that we say something. So this is invalid. It does not follow our law of syllogism. Okay, second one. If you are an actor, so that's our yellow, then you enjoy theater productions. That's our orange. So notice what they did here is we don't have any blue. We've cut it out. Okay, we've started with our very beginning. If you are an actor, we've cut out that repetition of the blue, and we finished with then you enjoy theater productions. So this is valid because of our law of syllogism. Okay, it cuts out that run-on sentence for us. All right, let's do one last example. Okay, draw a valid conclusion from the given statements if possible, then state whether your conclusion was drawn using the law of detachment or the law of syllogism. No valid conclusion can be drawn. Write no valid conclusion and explain your reasoning. Okay, so if you are 16 years old, then you can apply for a driver's license. Nate is oh, no, not blue. That's not a new one. That would go with our yellow, right? Nate is 16 years old. So hopefully you're noticing that this statement does have repetition in the sense that we're talking about a 16-year-old, but it's not back to back like in our law of syllogism. So hopefully we could reason, right? If Nate is 16, it follows the beginning of the first statement. He's 16 years old. So then we can say our conclusion can be that Nate can apply for a driver's license. Okay, and since we had that break, we started the same, we're going to end the same. This is our law of detachment. Okay, and that is step 4. Thanks for watching.